Hello students, and welcome to Unit 4. In our first lesson we are going to look at one-step equations. Our essential questions for today are: how can I solve one-step equations? What are inverse operations? And what vocabulary terms are part of solving an equation? As part of your classwork portion of this lesson, you will also learn how to check the solution of an equation. So you've heard this saying before: it all starts by taking one step in the right direction. And you can translate this saying to one-step equations because with a one-step equation, it only takes one step to get a solution. That's why it's called a one-step equation. So what is an equation? An equation is a statement that two amounts are equal. You have been studying equations since kindergarten. Even in kindergarten, when you learned 2 plus 2 equals 4, you are looking at an equation. One amount is equal to another amount. Two equal amounts. Now, the difference between what you've learned before and what you're going to learn now is that in our study of equations, we're going to be looking at algebraic equations with the goal of trying to figure out an unknown value. And in this unit, we're going to figure out just one unknown value, so each one of your equations will only have one variable. Remember, an unknown value that we're looking for in this case is called a variable. A variable just means a changing amount. So an x in one problem may equal 5, but in a different problem it may equal 7. The variable is just a symbol that stands for an unknown value, and that symbol can represent more than one number given in a different circumstance. Now let's talk about a solution. A solution to an algebraic equation is any value of the variable that will make the statement true. In other words, the two sides are equal. So in kindergarten, when you had blank plus 2 equals 4, you were really solving an algebraic equation because you were saying this unknown amount is 2 because this is the only solution, this is the only number that you can add to 2 and equal 4. In other words, 2 would be the missing value that would make the two sides indeed equal to each other. Now, checking a solution is very important because if you can check a solution, you can know that you are either right or wrong. And if you're right, you're good to go. If you're wrong, you can go back and check your work. So let's look at an example. Is -2 a solution? In other words, does it make the equation true to the equation 2x plus 5 equals 1? So to solve this problem, to see if this is a solution, I want to know if I put -2 in for x using substitution, will it equal 1? Now, when you substitute a value, it's important to put it in parentheses so you don't think it's subtraction. This is really multiplication. So 2 times -2 plus 5, does that equal 1? Well, use your order of operations. We have multiplication and addition. We'll have to do multiplication first. 2 times -2 is -4 plus 5. Does that equal 1? Well, -4 plus 5 is 1. If you owe 4 and you have 5, then you have 1 left. So 1 equals 1. So yes, -2 is a solution. That's how you check the solution to an equation, and you will get more practice with that in class time. This substitution strategy, even though I just introduced it to you in the one-step equation lesson, works for any solution to any equation. Now, I want you to think about an equation as two equal amounts that we just talked about. And here you see that problem that I talked about from kindergarten, 2 plus 2 equals 4. I want you to think about this equation as being a balanced scale. Now I want you to think about this. If I would add 2 to this side, would the two sides still be equal? And the answer is no, because 2 plus 2 is 4 plus 2 more is 6, and 6 is greater than 4. So if I want to add 2 to this side, and I want the equation to stay equal, then I'm going to have to add 2 to this side. If I add 2 to each side, does adding the same amount to both sides cause the scales balance to change? And the answer is no. It remains equal to each other. It does change the value of each side, but the statement itself is still equal. Now let's look at the same problem and continue to think about an equation as a balance scale. If I would take 2 away from the left side, would it still balance with the right side? No, because this is 2 and this is 4, and 2 is less than 4. So to get it to rebalance, what I do to the left side, I have to do the right side. So since I subtract the 2 here, I'll have to subtract 2 here as well. Now both sides are equal because they both equal 2. So if I subtract the same amount from both sides, does it cause the scales balance to change? And the answer is no, because the two sides are still equal in value. Their numeric value has changed, but they are still equivalent. Now let's think about multiplication. If I multiply this side by 2, 2 plus 2 is 4, times 2 is 8 equivalent with 4? No, but if I multiply this side by 2 as well, then they both equal 8 and they are still equal in value. So does multiplying the same amount to both sides cause the scales balance to change? No, the two sides of the equation are still equal in value. Last, let's look at division. If I would take this left side and divide it by 2, would the scales be balanced? No. But if I divide this side by 2 as well, will the scales remain balanced? And the answer is yes, because they both equal 2. The two sides of the scale are still equal in value. So does dividing the same amount to both sides cause the scales balance to change? And the answer is no. The two sides are still equal in value. So the lesson we just learned in those last 4 examples is, if we think about an equation as a balanced scale, then the equation will remain balanced or equal in value as long as the operation performed to one side is performed to the other side as well. So if you summarize that as a big idea, what operation we do to one side, we have to do to the other as well. You can almost think about it as 2 siblings. If mom gives one sibling $20 to keep the other one happy, that she would get them $20 as well. Whatever you do to one side, you do to the other as well. So let's look at one key phrase that can help us solve a one-step equation. And this will actually help you solve any equation. And that is this phrase: use inverse operations to isolate the variable. And these are our key vocabulary terms that we should use when we're solving equations. So let's first talk about inverse operations. Inverse operations are operations that will undo each other. For instance, addition and subtraction will undo each other. If I start with the number 1 and I add 2 to it, and then I subtract 2 from it, I get right back to where I started. That's an example of inverse operations. Multiplication and division can do the same thing. If I have 1 times 2, that's 2. And if I do the opposite and divide by 2, I get back to where I started. There are 2 other sets of inverse operations, and I'll show you in a minute why they are inverse operations, but they are to multiply a fraction and to multiply the reciprocal. This is the one that most students confuse. They want to say that the opposite of multiplying a fraction is to divide a fraction. But when you divide a fraction, you multiply the reciprocal instead. So the inverse operation of multiplying a fraction is to multiply the reciprocal. And the last set of inverse operations, which we will not touch upon until later in the unit, is to square a number. The inverse operation is to square root a number. The opposite of a square is a square root. Now, we said that we would use inverse operations, so use those operations to isolate the variable. So what does that mean? To isolate the variable means that the variable appears by itself on one side of the equation and not at all on the other. So if you look, I've given you two examples. One of these has an isolated variable and the other does not. If you look at the equal sign and draw a line down the middle, that helps you decide the two sides of the equation. If you look at the left side of the first example, you can see that the only thing written on this side is the y. In other words, the y is isolated. It is alone. So this is an example of an isolated variable. This is a non-example of an isolated variable because you can see that the y is not all alone. It's being multiplied by 2. You can also see that it also appears on the other side. Therefore, it's not isolated for two separate reasons. That it occurs on both sides of the equation and it's being multiplied by 2. So, to solve one-step equations by using inverse operations to isolate the variable, follow these steps. First, look at the algebraic side of the equation. 2. Determine what operation is acting upon the variable. And 3. Do the inverse operation to each side of the equation to isolate the variable. In part 2 of this lesson, we will look at specific examples to show us how to apply these 3 steps.